Hi, good evening. This was one of the questions asked for your mock exam. I'll just read for the others who haven't got a chance to read the question. The luge is an event at the Winter Olympics. An athlete lies on a small sledge and races down an icy track feet first. An athlete accelerates down, this is important, accelerates down at a straight section of the track as shown. The track is at an angle theta to the horizontal. Draw a free body force diagram for the sledge and athlete. You should consider the relative sizes of the forces when drawing your diagram. Again, this is important, which is the relative, that is. So these are the key terms that you should have picked from the question. Now, first step, see it carries 4 marks. So it's not just for labeling the diagram. You have to also pay attention to this term. Now, what are the forces that are acting on him? Obviously, the weight that is acting perpendicularly down, and you have frictional force acting in the opposite direction of the movement, and the reaction force that is acting perpendicular to the surface. All right, so let's draw that first. So you have here, this way you have the frictional force, and you have the weight, sorry, weight acting downwards, and you have the reaction force which is acting perpendicular to the direction of, so perpendicular. We have identified the 3 forces. For this, you will secure 2 marks out of this 4. Now, as I said, the key term accelerates and relative sizes. So it is accelerating here, which means you need to have a resultant force in this direction, correct? Now, if you look at this, I've just made equal length for the forces. Now, will this be accurate? Will this be correct? No, it isn't, because you have to show that in this direction, the force is greater. How do we do that? Now, this here, is there any movement in this direction? No. So, there should be a component of weight in the same line as that of the reaction force, which would cancel this. All right. For that to happen, this vector or W must be greater than R, because if it is smaller, definitely its component is going to be much smaller, right? If these two are of equal lengths, the component in this angle will be smaller than this. Hence, we are not showing that these two are equal. So definitely this has to be greater than R for you to have a component of this W to be equal to R, so that that cancels out. So this is one point where W must be greater than R in this case. All right. Now looking at F. So these two are cancelled. So definitely you need to have, as we said, acceleration is greater here. So this length should be greater than F, right? So F has to be smaller than, sorry, F has to be smaller than W. So these are the factors. So as I said earlier, though it looks as a very simple free body force diagram, you need to pay attention to, finally, after breaking down into components, the resultant vector must be in this direction where it is accelerating. All right. So the correct diagram would be, this would be the correct diagram. As I was trying to explain earlier, you have got the reaction force to be smaller than W. The reason is why you need to, when you're taking the components of W, you must have an equal length for R, and when you make component for W, that on this line along the surface, it will be greater than F, which will make sure that the object is accelerating this way. All right, so this is the correct. That's end of part A. Part B will follow in another video. See you. Bye. Thank you.